Yes, I agree. Go to 9. Whoops. Point 1. Counting principles continued. So the other day we talked about the fundamental counting principle where you multiplied all the things together. We talked about factorial. We talked about combination, and we talked about permutation, right? So a lot of times as we're working through here, it all depends on what the question is asking. And so as you're thinking about that, there might be times where you're just looking at the number of things, or there might be times where you're asking of part of a whole, right? And part of a whole will be a combination or permutation depending on what you're looking for. So I want to just go back for a second. Here's example number 1, and let's see if we can figure out which counting principle we need to use to find this one. Okay, what if I wanted to know a password with 3 numbers, then 2 letters. Okay? No. So this one, if you think about it, and again, remember, this is saying that we have 5 places here in our password, right? The first 3 are each numbers, and the last 2 are letters. Agreed? Okay? So if the first one is a number, how many options do we have? 10. If the second one's a number, we have 10. Third one's a number, we have 10. But then the fourth one is a letter. How many options are there? 26. And for the last one, it would be 26. So you can either put this as 10 to the third times by 26 squared, or you can multiply them all out, right? This is a lot of options. But what if we were to change that and say with no repeats? Then how does it change what we're putting in there?
Oh.
Go ahead, Tyler.
You go 10, 9, 8,
Good.
26 times 26.5.
Good, yes, exactly. It would change that up. And so when you're counting down like that, what exactly is that? Factorial. Good. Alright, so here's example number 2. Nice job, you guys. Example number 2. So what if I came out and said, I want to make a committee of 10 from a class of 42. So now we're talking part of a whole, right? I want 10 out of those 42 possibilities. Okay? So first of all, it comes down to this is going to be either a permutation or a combination. How can we tell the difference? What's special about a permutation? Right, there's an order. Order matters on how it's going to happen. So does order matter how I choose these 10 people on the committee? No, I'm not saying I have a president and a vice president or anything. They're just 10 people. So in this one, you always start off with the big number, the whole, the 42, and this is choose 10. And of course, if you plug it in into your calculator,
147144297. What do you want to base?
147.
1442997.
Thank you. What, Tyler?
How do you get that big C?
Yeah, if you go into math, go over to probability.
Oh yeah, I remember you told that.
Okay. I guess I could fix. I'm being kind of sloppy here. Those people that are at home. There we go. Okay? So you're going to have a few of those today. But what if we make it compound now? What if not only if I'm using the same thing, instead of saying I want 10 from the whole class of 42, what if I say I want 4 out of 26 to be boys and 6 of them out of 20, well, the other 14, no, 16 to be girls, right? What if I change it up like that and I got 2 things going on? So let's write an example closer to that. So example number 3. Let's say I want a committee made from let's say 6 out of 20 boys, men, whatever, and 4 out of 21 girls. Oh my goodness, there you go. Okay? So this is a compound thing going on. We have this and this happening together. So anytime you have 2 things that are happening together, we are going to put them together. We're going to put them together in a special way. So we're going to start with this one first. This, if you were just doing that, would be 20, choose 6. And then if we were just doing this one, it would be 21, choose 4. So anything I'm going to put in the middle?
Oh, multiplication sign. Add. Plus.
Plus, there we go. We're going to add them together. The combinations of this one plus the combinations of this one. Okay? So you can type it into your calculator just like that. You can type it in where you get the first one, you type it in, get the second one, and then add them. Okay? It's up to you how you choose to put it in. Totally your call. Or you can use the formula. So in this one, let's see if we can all calculate that one.
$44,745 different options.
Is that what you guys got? Say that one more again, Tyler.
44,745.
Thank you. Yeah, so you guys are faster than me. I didn't get in the calculator that fast. Alright. So does that make sense?
Yeah.
Is there a question on that?
No. Please.
Alright.
Start our homework.
No, I'm not done yet, but thanks. Okay. Example number 4. Talk about another possibility of how it could happen. What if I'm thinking there are 5 options for lunch. Okay, you have 5 options for lunch. How many possibilities if you can have at least one? So when I say it that way, what I'm saying is, out of those 5 options, you're going through the lunch line. You can choose 1, you can choose 1 and 2, you can choose 1, 2, and 3, you can choose 1, 2, 3, 4, or you can get all 5, right? Or maybe you choose the first one and the last one. Maybe you choose the first one, the third one, and the last one. How many options? What do you think we can do for this?
5.
5 what?
5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5. Add them all together.
You're very, very close. Instead of times, what else would we put there? You're close. What did we just use in the last couple of times?
C.
C. So yes, we're going to do 5, choose 1, plus 5, choose 2, plus 5, choose 3, plus 5, choose 4, whoops, plus 5, choose 5. Because maybe you want all 5. Maybe you want 4 out of the 5. Maybe you only want 1. Okay, so now how do you want to put this in our calculator?
Just type it in like that?
You can. That's one option. You can type in each piece separately. So if you type them in separately, there's 5 options for the first one. There would be 10 for the second one.
Yeah, I got a 0, so. I have a typo for
There's something you're typing in wrong. 10 for the third one. 5 for the second one. And 1 for the last one. Should have gotten 31. So what if I added to that question and said, well, maybe I didn't like any of it? How many of you think that would add on if I said, out of your 5 options, you choose not to get any? 5, choose 0. How many think that would add to that? Wouldn't add 0, because it is an option, right? It would add 1, exactly. Okay? So, although it sounds like it should be 0, it would add 1 option if you chose not to get any. Okay? Huh? Correct. Alright. So last example, and I think I want you guys to try this so that if we have something to talk about, or as we go through it, we can work together on it, okay? So, how about something like this? Is this example 5?
Yeah.
Okay, thank you. Sorry. I want to choose at least 6 out of 10 books. I don't know, it doesn't really matter. Alright, so what do you think we should do?
Well, probably 6 first.
Okay, and that 6 is being chosen from how many?
10. So
So we're
3 10.
10, choose 6 is our first option. I said at least. So what does that mean?
10 choose 5, 10 choose 4, and
At least means what?
Well, if you go more.
Yeah. Yep, so they're going to go 10, choose 7, plus 10, choose 8, plus 10, choose 9, plus 10, choose 10. Just in case. You choose all 10 books. Is there any question on what we're trying here? No questions? Okay, so I have 23 through 38 all there. It really isn't that many problems. Most of them, again, you're just typing in your calculator. I'd like to see the formula you choose to use, like whether you use P or C, or like this, have that down. Now, just give me the number, okay? So I know what it is you did to get that number would be awesome. All right? You guys still have like more than 15 minutes to get this done. Okay?
Wait, wait. You want to see the answer to that?
What is the answer, Tyler?
Wait, so
Yes.
is it 386?
Yes, actually. Yeah.
Bring it on.
Good job, Tyler.